Hello viewers, welcome to my channel Science or Technology. In today's show, Rocket Monday, we're going to talk about hot staging. So let's dive deep into it. So what exactly is the problem? Well, problem is that in a parabola, meaning you are going up and you turn off your engine, for things that are inside you can reach what we classify as 0G or perception of 0G, meaning you will start floating. Now, human floating, that's cool and all, we pay for that. But when your propellant starts to do that, be it liquid oxygen, be it kerosene, be it liquid hydrogen, yeah, that's a bad time. That's like, no sir, that's just like bad. That's flat out bad time. So when this happens, well, the moment you trigger what we call MECO, main engine cutoff, the moment you have that signal and engine goes like, you are literally in 0G. The propellants inside are behaving YOLO. So they can literally start sloshing around for no reason. Like, I'm just like, yeah, I'm doing this. Like, this is in Saturn V, so be mindful. It is a serious thing. Now, thankfully, engine can create its own force, meaning it's creating action. That is like reaction going like this, meaning propellant, bam. So everything is awesome there. But here's the deal. That assumes engine is running. If engine is off, let's say during staging, your engine is off, how the heck you started? Because all of this creates a serious scenario where you cannot start at zero and your engine cannot handle void going into it. It will go kaboom into it. So this is the problem. Parabola creates a situation where things that are inside you will experience 0G. So fundamentally, all your propellant becomes unreliable because they are not at the bottom of the tank. They may be literally anywhere other than the bottom of the tank. So that's a very serious issue. And you cannot start an engine at that point in time. I'm like, you can risk it, but kaboom will wait you. So there was a great meme. In trust, we thrust. In thrust we trust. So thrust is the only answer that we have. So basically you have to push the rocket. Basically you have to push it gently, brutally, whatever have you, but you have to give some extra love to it. So once the engine starts, then it's a self-sustaining thing. You do not have to worry about it, but you have to be damn sure that you are not feeding void into the engine. Void goes into the engine, turbo pumps goes kaboom. After that, even bigger boom happens. People have learned this the hard way. So trust me, void, engine, working second stage, yeah, you will no longer have a second stage. So that's a very known fact, very serious thing. So how do we achieve this, that kick? Well, you can start with springs. This is a electron rocket, and you can see that, like, the video was amazing. You can see actual springs coming out doing footing like this. Like, you can see the springs are here compressed, swing. There are multiple swing, obviously. So this is the easiest thing because this will create a scenario where the chassis is moving outward and propellant is forced into the backward side. At that point in time, engine can spool up. Engine is like, I got this. The engine will ignite. Bam! It's like, I've got this. No problem. I got this. So that's one option if you are light enough. Second option is ullage motor. Like, this is Saturn V stage 3, and whenever you see like those 3 small boosters that are going on, those are ullage motor. Now be mindful, there were grand total 6, as in 3 that were pushing it outwards, 3 pushing it backwards. Now why? Well, they wanted to be damn sure that when they ignite the engine, nothing is close by. So if engine creates a cloud of gas which has enough velocity, if it is making love to basically like interstage, yeah, it's gonna cause kaboom, and that could create shrapnel in vacuum stage, which could be very, very destructive. So they've always wanted to make sure there is a clean separation. So how do you achieve clean separation? You have 3 boosters that are pushing out. Now again, when I'm saying booster, I mean light boosters. They are just like nudge it, and there are 3 boosters that are decelerating the basically preceding stage. So decelerating, accelerating, that creates a wide gap. Computer detects the gap, then it ignites the engine. And this also gives you leeway. For example, you like in spring case, you only have certain margin of momentum. Of course, modern engines are like, damn sure if we're gonna ignite it, it's gonna work. But back in those days, they needed some breathing room where they're like, no, we are damn sure the engine's gonna work. So ullage motor did have some burn time, so few seconds of burn time. So they could be like, yeah, I got this. Not even few, even if it's like 1 whole second, that's more than enough compared to spring. So that's why they do it. And this is basically Falcon 9. So you have these 2 options of simple options where you have either push it by a spring, use ullage motor, which we no longer do, or you can use onboard thrusters. Now thrusters are most long-term solution because if you have to do it multiple times in upper stage, it can be done. That's a desirable thing, meaning if you are making a second stage rocket, that may need to turn off, reignite again and again. Even if you have an engine and chemistry that can do that, you may have an issue where it's like propellant is not behaving. So thrusters are your best friend at that point in time. So these are the 3 options where we put some extra love into it, and then we say, in thrust we trust. So this is how we achieve it so far. Now there is a violent option which we call hot staging. Basically, this is a point where you do not wait for main engine cutoff. You just go YOLO on it. Basically, engine is pushing you. The first stage booster is pushing you. Of course, it's reaching a throttle down phase. Basically, it's running most of the part, and you may even have a basically control graph where it's like, okay, sir, now it's your time to chill, relax. Then you fire the second stage. While you are attached to the rocket, be mindful. The booster is only working, and you are also attached. You are physically attached to the main system, and then you fire the engine. So therefore, it's classified as hot. Everything is hot. All engines are working. Everything is connected. So how can you find a rocket that has hot staging? Well, easiest way, there would be some skeleton pieces. For example, if you see a rocket that has way too much hole, or this is N1 rocket, you can see way too much holes. Those were designed for hot staging. Whenever you see giant gaps, hot staging. Do not think too much about it. You see giant gap, it generally is for hot staging. Otherwise, it does not make any sense to have holes there. So fundamentally, you have that. Now, it is far more violent compared to all other options. Springs, mild. Ullage motor, expensive, but done. And thrusters, really awesome. But this puppy is like brutal. Like this is a Titan rocket, earlier variants of that. And you can see that like engine takes some time, like a liquid system takes some time to spool up to reach to like full oomph. They start the fire, the vent is basically able to absorb it and dissipate that. And then you see the engine starts to build up. It's like, and the chassis is like kaboom. So this is really rough. Not only the second stage, also on the first stage. So it is a bit more violent system. That's why it was preferred in the early days. But now they are like, yeah, no, we don't prefer it. However, it does have one awesome benefit. No need for auxiliary equipment. As long as you can time your engine ignition, as long as you can control it, at the end, you don't need anything else. And if you're making an actually useful rocket, you should have that. So fundamentally, it removes, you no longer need springs, you no longer need ullage motor, you don't even need thrust. So let's say, for example, if you are making second stage, you can rely on the engine gimbal only. You don't need thrusters or separation. So that was the logic bit and N1 rocket. So there is some serious benefit. And another benefit, because you are never shutting off, your momentum is constantly maintained. There is no point where it's like, it's not going like that. Like the velocity is constant, very smooth. So you do get bit of payload boost, little bit, but you do get it. And if you're talking about a big ass rocket, that little bit does pile up to a very big number. So that's what we call hot staging. Many countries do that. For example, India's GSLV Mark II, and United States, Russia, all of that. So what about Starship? Now Starship, the current system which they had, which many people are thinking maybe they actually did not intend to actually use it, because what they were trying to do is yeet it. I'm not joking. That's what their design was like. Do this. And I'm like, you want to put people in something that you are doing like this. We are not satellites. Not a good thing. So it's a bit odd. And if you are like, why the heck the rocket was cartwheeling? That was by design. This command was given to do cartwheeling. It's just that stage separation did not work. So that's the odd thing. And again, the test mission showed the world is like, yeah, no. It's one of those things that it does work. SpaceX have been using it for second stage and Starlink satellite launch. It is a known system. It does work, but it's just like for something this huge, something this heavy with this much propellant inside, maybe not a good idea. So it's one of those things that odd. Now let me be very clear. In physics, it works. It's just like, do you really want to push it? So that's there. Now, if SpaceX goes to basically hot fire stage, they gain few tons of extra payload capacity. Now they are claiming they will gain 10 tons. I will put it conservative 5 tons. Let's see in the real world numbers. Now it should help them. That's a known thing. And what they would need to, in terms of modification, they have to elongate the basically booster, and they have to reinforce it. Now here, this is the hassle for them, because they want to reuse the booster, and the booster is gonna make love to direct engine exhaust. So that's a very serious issue. So that means that system, I do expect their first booster, even if it lands perfectly, they're not gonna reuse it. They're gonna analyze the hell out of the top part, which literally survived rocket engine firing to it. So I do expect this will increase the cost of the upper stage of the boosters. So that's there. And how they're going to achieve separation? If this engines, like let's say 21 engine is going YOLO on it, or 33 engines are going YOLO on it, there is no amount of 6 engine that will allow you to separate, because again, booster will be pushing you so hard. So what they're going to do is shut down majority of the engine, only run on 3 engines, and at 50% throttle. What does that mean? That simply means they're effectively getting acceleration of 1.5 engine. and they're gonna fire 3 engines of sea level 3 engines of the Starship. So that would be like 3 engine acceleration versus 1.5. So that should, in principle, allow them clean separation. Now be mindful, it is hot firing and it is violent. So do not expect a like a ballet kind of dance. Do expect some dunk kind of thing, but it should be doable. And be mindful, all these details, that 50% 3 engine, I do expect it to change. I would be actually shocked if none of these change. I genuinely am saying that, like flat out. I do not think they're gonna follow these things. Of course, they will fine tune it. They may try with this, but then they will fine tune it. This is an amazing picture from Tony Blair. You can go in his Twitter and find it. So what we can expect in the future? Well, here's the deal. It's a rough system that they want to implement. It's not a gentle system. It is something a bit more clunky, I would say. So it is a rough system to it. Now, it could delay their human rating for Earth system. Now, whenever you are building something, it is rated for 2 classes. One is space, one is basically launch. Launch is much more brutal. So does SpaceX have any launch rated system? Yes, they have Dragon. That's sorted. So all they have to do is make sure this puppy goes into space safely, without humans inside it. So it can be done. So they can do Artemis if they want to. But having this sort of hot staging while you have people on there, yeah, that may delay the, basically NASA may require, hey, can you please do it like 100 times before we trust you? So I do expect it to take long amount of time for human certification at launch. Now, can this be used as a launch escape system? Well, physics is saying no. So probability is very, very low. Why is that? Well, they can only fire 3 engines here because unless they are using the same nozzle geometry that was used in RS-25, as in like space shuttle, those basically vacuum optimized engine, if they fire that puppy on Earth, it's gonna go kaboom. So fundamentally, because they will have what we call wall separation. Nozzle, the gas flow, that's how it should be. Gas should be making love to it. But if gas happens like this, it causes oscillation, and that oscillation equals kaboom. So fundamentally, unless they are using that sort of nozzle profile, I do not trust them. They will have the ability to ignite all 6 engine, even if they want to. Now here's it, that gives them 3 engine, known fact. But let's be optimistic. Let's assume they have all the 6 engine ready to go. But here's it, these are liquid engines, and they have electrical ignition system. Now they can be fired very quickly, but can they fire as quickly as a solid booster? No. Solid booster is like electrical impulse equals go. This electrical impulse start doing things and hope that you can get things done. So the time gap, like let's say booster goes kaboom, and how long they have before they actually start to fall down, and how long they have before the engine spools up, creates enough thrust then actually travels faster than the fireball. Yeah, that's very, very raw impossibility almost. So acceleration, and even if, let's say, even if you can spool up the engine, let's say for some safety reason they figured out, what if we have the engines running in some sort of nitrogen mode where it's already spooled up, they can ignite it instantaneously. Will it have enough thrust? Like thrust of like a solid booster is a different kind of power graph, so to say. It's like here it's like, it's far more gentle. Fundamentally it's gentle. So I do not see that probability paying out. Again, I could be wrong, but likelihood is low. But it should be much simpler than yeeting the system. So I do expect that yeeting the system to be gone away. That makes sense for satellites. Does not really make sense when you are talking about a second stage that's supposed to have people inside them and giant heat styles. So let's see what happens in the future. It would be interesting to. Now be mindful, this is amazing work by many SpaceX fans, but I do not expect this design. Design could change. Now be mindful, even if you see a design, there's a very good chance when by the time they're actually using it as a paid launch system, they will change it. So expect nothing. So this was my presentation on hot launch. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.